Good afternoon to all of you. Myself, Professor N.V. Adpe from SNT College of Engineering and Research Center. Yoga. Now, in previous lecture, this is a lecture series of electrical measurement and instrumentation subject. Now, in previous lecture, we have studied the uh, detectors and sources of AC bridges and general equation of bridge balance condition and Maxwell inductance bridge. Now, in that lecture, we have discussed about the Maxwell inductance capacitance bridge and Anderson bridge. These bridges are used to find the value of unknown inductors by using AC bridges, by using the comparison of capacitors, inductors, and resistances. Maxwell inductance capacitance bridge. In that type of bridge, the unknown resistance is measured with the help of the standard variable capacitance. The connection diagram of the Maxwell bridge is given below. There are four arms like a Maxwell bridge. In first arm, there is R1 and L1 are connected in series. In second arm, R2 is connected. In R3, there is resistance R3. And in R4, arm 4, there are variable capacitor and variable resistors. Variable capacitors and variable resistors are connected in parallel. In that, the source is connected between A and C, and the detector is connected between B and D. Now, the L1 is unknown inductance of resistance having resistance R1, R1 having variable inductance of fixed resistance R1, R2, R3 and R4 variable resistance connected in series with the inductance L2. Inductance L2. The R2, R3 and R4 are the variable resistance, C4 are the variable capacitance. Now we can find the value of R1 and L1 by using the bridge balance condition. By using bridge balance condition, that is Z1, Z4 is equal to Z2 into Z3. Z1 is equal to R1 plus J omega L1. Z4 is equal to 1 upon J omega C parallel with R4. That is R4 upon 1 plus J omega C R4. C4 R4 is equal to Z2 into Z3. That is R2 into R3. Rearranging the terms by multiplying these terms, R1 R4 plus J omega L1 R4 is equal to R2 into R2 plus J omega C4 R4 into R2 R3. Separate the real and imaginary parts, then R1 R4 is equal to R2 R3, then R1 is equal to R2 R3 upon R4. This is your final equation for finding the resistance of inductance. Now compare the imaginary terms on both sides. Then L1 R4 is equal to C4 R4 R2 R3. R4 R4 get cancelled. Then L1 is equal to R2 R3 into C4. This is the method or this bridge which is used to find the value of unknown resistance and inductance through that method. The quality factor is expressed as a Phasor diagram of Maxwell inductance capacitance bridge shown in figure. Q is equal to omega L1 upon R4 is equal to omega C4 R4. This is your quality factor of method. This is the Phasor diagram of Maxwell's inductance capacitance bridge. I1 R1, the resistor, we take the reference I1 take the reference I1 uh, in I in for star I1 R1 and R1 and L1 are connected in series. Therefore, the voltage of R1 is in series with the current and the voltage of L1 is 90-degree lead to the I1. Then this is the this is I1 R1, this is I1 omega L1. The combination of that, this is your E1, that is E1 is equal to E1 and E1 and E2 are equal, that is E2 is equal to I2 into R2. Therefore, R2 and the resistance, the voltage of resistance in phase with the current. Therefore, to extend this line, and this is your I2. This is your I2. Then this is to take the IC in 90-degree leading. In 90-degree leading with R4 voltage current 90-degree current lead. IR will be in series in phase with the current I1. Then the addition of IC and IR, this is your I2. IC and IR, this is your I2. This is I2, I1, E1, E2, then E3. E3 is nothing but I1 into R3. I1 into R3. This is in phase with the I1. Then the addition of E2 and E1 and E3. This is your total induced EMF or the total voltage of your supply. This is the total supply. The addition, phasor addition of E2 and A3. This is your total voltage. This is the phasor diagram of Maxwell inductance capacitance. This is the derivation. The advantages of Maxwell's inductance capacitance bridge, that is the balance equation of circuit is free from the frequency. Both the balance equations are independent of each other. The Maxwell inductance capacitance bridge is used for the measurement of high range of inductance. The disadvantage is the Maxwell inductance capacitance bridge requires a variable capacitor, which is very expensive. The bridge is only used for the measurement of medium quality coils. This is the advantages and disadvantages of Maxwell inductance capacitance bridge. Now next is the Anderson bridge, which is also used for the measurement of unknown inductance. For the measurement of unknown inductance, accurate measurement of self-inductance of the circuit. This is the advanced form of the Maxwell inductance capacitance bridge. R1 and L1 are connected in series. R2, in that R3, in between B and D, there is a one variable resistance, small resistance and detector, and in between C and resistance there is a connected capacitor C. This is the phasor diagram of Anderson bridge. To take the reference I1 into R1 plus R1 and I1 into J omega L1. This is your the phasor addition of these two is it is E1. Then IC plus the I2. I2 is equal to I4 plus IR. I4 plus IR. But these These ICR will be calculated from the E3. E3 is equal to I1 into R3. I1 into R3. This is the phasor diagram. Then the addition of this is the ICR, and the addition of ICR, IC and I4. This is your I2, and in the phase of I2, that is your E2, that is I2 into R2, and E4 is equal to I4 into R4. Then the addition of E1, E2, E3 and E4. This is your total induced EMF. This is the phasor diagram of Anderson bridge. The advantages and disadvantages of Anderson bridge. It is very easy to obtain the balance point at Anderson bridge as compared to Maxwell bridge in case of low quality power, low quality factors. There is no need of variable standard capacitor. This bridge also gives accurate results for the determination of capacitance in terms of inductance. The disadvantage of Anderson bridge is the equation obtained for inductor in this bridge is more complex. The addition of capacitor junction increases complexity as well as difficulty of shielding of the bridge. This is a Anderson bridge. Okay, thank you.